What exactly is closure property? We all know a set. A set A contains elements. This is a set of natural numbers. A set is said to be closed if all the elements of the set are of same type. And of same type, I am referring here all being natural numbers. Let's quickly study the closure property on whole numbers. Now, we said initially that there is a set. If that set contains whole numbers, in order that the set has to be closed, it needs only whole numbers. It cannot have a non-whole number. If we are performing an addition operation over two numbers, let's say 11 is a whole number and we add 7 to it, so it becomes 18. 11 is a whole number which belongs to this set. 7 is a whole number which belongs to the set. 18 is also a whole number. Can 18 be included in this set? Yes. Why? Because it's a whole number. It means that the whole numbers are closed under addition, which means if you perform addition as an operation on two whole numbers, you get another whole number and the set is said to be closed. A better example. So I am taking two numbers. 11 is a whole number, 2 is a whole number. I am dividing 11 by 2. Is the result a whole number? The answer is no. Now the set is said to be closed. If 11 is a whole number in the set, 2 is a whole number in a set, and the answer of this division should also be a whole number, which is not the case, which means this set is not closed, which means whole numbers are not closed under division. Let's look at multiplication now. Let's say 7. And you multiply it with another whole number, let's say 6. The answer is 42. So 7 is a whole number, 6 is a whole number, 42 is also a whole number. Try various options. There is a set which contains 7, there is a set which contains 6, the outcome of which is also a whole number, and that can be taken as a part of this set, and this set can be said as closed, which means whole number are closed under multiplication. Let's look at subtraction now. Let's take an example of 11 is a whole number, 2 is a whole number. Subtract 2 from 11. The answer is 9, which is also a whole number. Great. Try various options. Let's do the reverse now. Let's take 2 minus 11. So the answer is minus 9. So minus 9 is not a whole number. So which means a set which contains 11, the set which contains 2. But a set can contain 9, but a set cannot contain minus 9. Cannot. Reason? For a set to be closed, all the numbers have to be whole numbers, whereas minus 9 is not a whole number. Whole numbers are not closed under subtraction. Let's look for closure property for natural numbers, integers and rational numbers. Let's take an example. What happens in case of addition? When you add two natural numbers, do you always get a natural number? The answer is yes. So natural numbers are closed in addition. So they are closed. What happens when you subtract? For example, you take a natural number 11 and you subtract another natural number 19 from there. Do you always get a natural number? The answer is no, which means the natural number are not closed. What happens in multiplication? When you multiply two natural numbers, assuming 11 you multiply with 47, these are two natural numbers, you always get a natural number. So then natural numbers are closed in multiplication. And what happens in division? There is a number 11 and you divide one number 11, you divide it by another number 2. Do you get a natural number? The answer is no. You may get it sometimes. For example, 6 you divide with 3, you may get a natural number. But 11 divided by 2 does not give you a natural number. So, natural numbers are not closed in division. Similarly, we can find it for integers and similarly we can find it for rational numbers.